This here is a DAC module, or digital to analog converter. As its name implies, this module could create analog voltages and can set the output values using digital numbers. The Arduino, for example, doesn't have a DAC, only ADCs. That's why this module is great in order to have a steady DC output. You'll see that it's also capable of generating signals, and that's also interesting. So stick around in order to know more about this module and how to use it. So guys, let's get started. Hey guys, as you all know, this video is sponsored by PCBWay, and don't click away just now because I want to tell you how you could win free coupons up to $200. So if you go to the link below, you will see that it's the 8th anniversary of PCBWay, and you can get free coupons up to $200, and if you scroll down, you can find 50% off for 3D and CNC services. You could also enter the lucky draw and win sensors, microcontrollers, soldering machines, and so on. And you could also submit your own video, and each approved video could get from $5 up to $50. So you can check right now the anniversary page and also take advantage of the PCBWay incredible services and quality for PCBs, because I use them all the time for my projects and I get the results that I want. So you should do the same. So guys, let's continue with the video. What's up my friends, welcome back. This is the MCP4725 module. And this is a DAC, or digital to analog converter. It means that we can send digital instructions to it and it will output a steady DC value. But it could also create analog signals, such as a sine wave, a sawtooth, a triangle, or square signals. So it could be just like a small function generator, but as we will see later, it has its limitations. So this works with I2C communication. So we connect the SCL and the SDA pins for the clock and data to the pins of the Arduino, pins A4 and A5, as always. The module works at 5 volts, so we can also connect the supply and ground from the Arduino. And on the out pin we get the output. Before we see the code and some other examples, let's check the specs. This is a 12-bit DAC. And 12 bits is quite a lot. That means that we can use digital values from 0 to 4095. And working with 5 volts, that equals to a precision of only 1.2 millivolts for each digital state. So basically we divide the scale from 0 to 5 volts into 4095 steps. And each step is equal to around 1.2 millivolts. So the question is simple. If 4095 is for 5 volts, what value should we send for, let's say, 3 volts? Well, it's the simple rule of 3. We should send 3 multiplied by 4095 and divided by 5, and that equals to a value of 2457. Quite easy, right? But the current output is very low, so we can't use it as a supply, so be careful. We can only use it as a voltage reference, and later we will see some examples. By the way, it also has a small EEPROM memory incorporated. So using that, it will store the last value, and in case of the module resets or loses power, when it starts back up, it will continue with the last stored value. The I2C address by default is 0x62. But if you want to use multiple modules like this one at the same time and have different addresses, you can use these small pads on the module to change the address by making a solder connection to ground or VCC. So guys, make these connections between the Arduino and the module, and then we run the Arduino IDE. Now go to Sketch, include library, and open the library manager. And here we search for MCP4725 and select the Adafruit library and install it. Then you can download from below this first example code. As you can see, we import the needed library. Then we start the I2C communication with the 0x60 address, because my module has the ADDR pin connected to ground. And then we use the set voltage function to set the output to 1, 2, 3, 4 and 5 volts, with a 2-second delay in between. So upload this code to the Arduino and connect the multimeter at the output. And as you can see, each 2 seconds the value jumps 1 volt. But we can already see that the values are not exactly 1 volt, 2 volts, 3 volts and so on. So we must tweak the digital values in the set voltage function, and that's because probably the VCC value of the Arduino is not exactly 5 volts. As you can see, with 4124 instead of 4095, we get perfect values. So let's set it to 3 volts and take a look at the oscilloscope. And as you can see, it is a steady line. There is no switching at all, and that's great when you want a voltage reference without any noise. Now let's see another example generating signals. And this is the code for that. And as you can see, we now create a lookup table with the values for our signal. This is for a sine wave of 9 bits. This one is for 8 bits, 7 bits and so on. So let's check the results on the oscilloscope with a resolution of 9 bits, and as you can see the signal is very smooth. Only if we zoom in almost to the maximum, we can see some small steps. But now let's do the same with only 5 bits, and as you can see this vector has only 32 different steps. With fewer bits it's obvious that we can see the steps of the DAC. But on the other side, with 9 bits it was practically a perfect sine wave, and we can't see any steps. But anyway, we can always add a capacitor at the output to smooth the steps a little bit. Now let's make another code. This time we read the input from a potentiometer and create a delay. Varying this delay, we can change the frequency of the signal. So upload this new code and add a potentiometer and a push button. As you can see, we can now change the frequency as well. Also, if I push the button, we can change the signal type from sine wave, triangle or sawtooth. One thing that you can notice is that the maximum frequency is only 62 Hz. And that's very slow for a function generator, right? The I2C communication of the module works at 400 kHz, but even so, because we need to send so many bits and so many values for each wave, it limits the maximum frequency. But anyway, at a low resolution, we can get to higher speeds than only 62 Hz. So guys, what could you use this module for? Well, as a first example, you could connect it to a VCO, or voltage control oscillator. By changing the voltage here, you can change the frequency at the output. So you can make such a circuit using op-amps, and in this case the frequency could get a lot higher. And also, having a 12 bits DAC, we could precisely control the signal frequency. Using 2 op-amps, you can get a triangle and a square wave oscillator very easy with this circuit. And instead of using op-amps, you can make an oscillator with a 555 timer, using this circuit instead, and go up to 1 kHz. And another use is to control a load. Remember this project of a variable load? If not, you can check the video below in order to know what I'm talking about. Because for that project I was controlling the voltage at the MOSFET gate using this DAC module. With that we can precisely set the voltage in order to regulate the resistance of a variable load, and this was the schematic. And if you want to use a higher voltage than only 5 volts, you can always add an amplifier at the output with a certain gain. And another idea that I have in mind is to connect the DAC output at the input of a buck or boost converter like this one. The output of this converter is controlled by the voltage value set by a potentiometer. So instead of that, we can set the voltage with our DAC, and like that we can create a digital supply, as I did in one of my previous videos. But this time, instead of using the Arduino to create the switching signal, we can use the dedicated IC of the converter, and we only have to change the voltage at the control pin. And that should make an interesting project, right? Well guys, that's how you can use the MCP4725 DAC module. You have the example codes and the library below ready to download. So check more information on electroops.com. I hope that you have learned something new, and if so, consider giving me a like or comment below. Thanks again and see you later guys. Hey, so one more video that ends, I hope that you like it. Okay, so listen, if you want to buy my merch, my t-shirts, you have the links below for my shop, and I promise that I will make more designs. And also maybe you would comment below which one you like more and what more designs you would like to see, because in that way I could start designing them and post my new t-shirts. So thank you for all the support, and I'll see you in the next video.